Okay, everybody, today we're going to be moving on to the next section of advanced topics. This time we're going to be talking about rationalizing the denominator with radicals. So let's go ahead and get started. So the main principle of this is we can't have a radical in the denominator. The reason that is when they did long division back in the day before calculators, dividing by a radical on the outside was very difficult to do. And as you know, that would be the equivalent of 5 divided by radical 2. Having this number be an irrational number was very difficult to divide by hand. Now, of course, with calculators, it's much easier, but that is the purpose of why they wanted to rationalize the denominator, which is getting that radical out of the denominator. So let's take a look at our first example. Here we have 1 over radical x times 1. If we multiply it by 1, what is the result? Well, hopefully you guys will see that it's just going to be itself. If you multiply by 1, the value remains the same. The other principle you need to understand is what happens when you multiply radical x times radical x. Well, this is the same thing as the radical of x squared, and taking the square root of something that's squared is essentially undoing the squared or undoing the radical. So it just becomes x. So anytime you see two radicals times each other like that, let's get some better colors here. Anytime you see two radicals like that, no matter what's underneath the radical, it's going to come out. So for example, square root of 5 times square root of 5 is equal to 5. How do I know that? Well, because the square root of 25 is also equal to 5. So using that principle, that's going to be something that's going to be important. So how do we rationalize the denominator? Here we get to our star. So we already determined that we need to multiply. If we multiply by 1, we can do that, and it doesn't change the value of the expression. So we want this to be equal to 1. Now, over here, if we put 1 divided by 1, the value stays the same. So as long as we take the same number divided by itself, it's still equal to 1. For example, 2 divided by 2 is still equal to 1, and so on. So what value would get that radical x out of the denominator? Well, we already determined in the second example that if we multiply by radical x, let me make this red just for emphasis. If we multiply by radical x over radical x, that will get the denominator free of the radical. Now, of course, when we multiply the top times the top, the bottom times the bottom. So what is the result? Let's start with the top. Top is easier. 1 times radical x, which we can simplify in just a second, over what happens to the bottom. The exact case over here. If we have radical x times radical x, we're going to get radical x squared, or just x. You'll notice that it went from radical x to x. Now, did the value change? No, the value stayed the same. We multiplied by 1. We just changed how it looked. A lot of math is just manipulating the equation to get the value or the appearance of an expression that you want. And now we have the appearance that we want. So we can simplify this. Whoops, that is not my pen. We can simplify this further, and we get radical x over x, and that is how we rationalize the denominator. Let's get to some examples. The first moon. Now I know what you're thinking, that's no moon. You may be correct, but we're just using it as an example placeholder. So not equal to, we want to multiply this by 1. As long as we multiply the same thing in the top and bottom, that is equal to 1, so we can do that. So we get 3 radical 7 in the top. There's no simplifying that. And 7 in the bottom. Always check to see if you can simplify the coefficients in front. Does 3 go into 7? It does not. So this is going to be your final answer. Okay, next one. We have 5 times radical 2 over radical 5. So we're going to multiply both the top and bottom by radical 5. Again, that value is equal to 1. The only thing we're going to do is we're going to change how this looks. So we get 5 in the bottom, radical 5 times radical 5 equals 5. It undoes the radical when you multiply it by itself. And then we have 5 radical 10. You're going to multiply the two numbers inside the radicals together to give you that term. Now, of course, like I said before, we're going to check to see if the constants can be reduced. In this case, they can. you can cancel out completely the 5 with the 5, leaving you with radical 10, final answer. If ever I'm going too fast, make sure to pause, rewind, whatever you need to do in order to comprehend everything that I'm talking about. So let's continue. I think we're going to do one more example, then we'll make this a new video for the second part. So negative 6 over radical 12. Now the first thing, anytime I see a number like radical 12 that I know can be reduced, I like to reduce it first. So the first thing I'm going to do is reduce the 12. How do I reduce the 12? Well, we have numerous videos on how to simplify radical expressions, but I'll show you just a quick sum up anyway. The first thing I do is I get it into a factor tree, and I'm looking for pairs. Now, you can't leave the house being the radical sign, unless you have a pair, unless you have a date. So only one of the pairs can leave the house. So a 2 is going to leave the house. But the 3 has to stay home. He has to stay in the radical because he does not have a pair. So it ends up being negative 6 over 2 radical 3. Now, I want to show two quick things. One, we could cancel the 6 and the 2 right away if we wanted to. But just to demonstrate another property and another way to solve these types of expressions and rationalize the denominator, a lot of people it's not necessarily a mistake, you can still get the correct answer, but it's going to give you a more complicated answer. A lot of people do this. They multiply by 2 radical 3 over 2 radical 3 because that's what it says in the denominator, so I'm going to multiply that by the top and bottom. You're not wrong, but you're not doing it the most effective way. Okay? So what you should do is just multiply by the radical 3 over radical 3. The value is still equal to 1, just like it was before, but now we have less to deal with. And the whole point was to get rid of the radical. We don't really care about doing anything with the 2. The 2 can stay. So make sure if there's a radical and a constant, we are only concerned with getting the radical out of the denominator. Don't worry about the constant. So set that equal to, now let's do the bottom first. 2 times radical 3 times radical 3, we get 2 times 3. Radical 3 times radical 3, 3. Then we get negative 6 times radical 3 in the top. Let's simplify. Negative 6 radical 3 over 6. Now it's time to cancel. And we get negative 1 radical 3 over 1, or just negative 1 radical 3, or just negative radical 3. Both these answers are correct. So this is where I'm going to pause it. I'll see you next time when we talk about rationalizing with higher roots like cube roots and fourth roots. See you then.